All right. So next thing we're going to do is we're going to find your roots and your multiplicities given equations. So anytime you want to find your roots, you should always start with, I'm going to try to factor. Like that should be step one. If you can't factor, that's when we're going to get into rational root theorem and all that stuff. So if we were going to factor this, we would start, we're trying to find numbers that multiply to give us negative 36, but add to give us negative 5, which would be negative 9 and positive 4. So that means that you have to pay attention to the fact that these are to the fourths and squareds. So that means that this is, your factors are going to be x squared minus 9 and x squared plus 4. So not just x minus 9, x plus 4, because those are at such a high power to start. You want to factor as far as you can factor. So this is a difference of squares problem. So we can break this down into x plus 3, x minus 3, and then x squared plus 4. There's no such thing as sum of squares. That's as far as that one goes. So then you would go through and you would say, okay, if I find this root, x plus 3 equal to 0 is going to give me negative 3. I only have that factor one time. So if I only have that factor one time, this is going to have a multiplicity of 1. Then I'm going to set this one equal to 0. That's going to give me x equals positive 3. I only have that factor one time, so that also gives me a multiplicity of 1. Last one, if I set this equal to 0, x squared plus 4 is equal to 0, I would subtract 4, and I'd get x squared equals negative 4, square root, square root. If you take the square root of a negative, remember that's your i's. So this is x equals plus or minus 2i, which is the same as x equals 2i and x equals negative 2i. So both of these have a multiplicity of 1. Remember, your multiplicity should add up to your degree. So 1 plus 1 plus 1 plus 1, that gives us 4. So that checks. All right, next one. I'm going to try to factor. So if I try to factor, I end up getting that I can factor out an x squared here, and I'm left with x plus 3. If I try to factor over here, the biggest thing I can pull out is a negative 2, and that leaves me with 7x plus 10. So this is an example that's not factorable, all right? So always try to factor first, so this one ends up being not factorable. So if it's not factorable, there's really only one thing you can choose to do at this point. So the only thing that you can choose to do at this point is to use that rational root theorem and go through and do that. I would show you that here, but we actually do that on the next page, I think. Let me make sure. Yeah, we're going to do it on this page. So for the sake of this one, I'm going to kind of skip over it, and then if you need extra help, you can always go back to it. I'll set it up for you, so if you want to try the rational root theorem to give yourself a little extra practice. So it would be all the factors of 20 over all the factors of 1. So you'd have plus or minus 20, plus or minus 10, plus or minus 5, plus or minus 4, plus or minus 2, plus or minus 1, all over plus or minus 1, which obviously just gives you that these are all your combinations, and then you would use that synthetic division to solve from there. Okay, like I said, if you want to practice it, go ahead and practice it. Next one, describe behavior around the roots based on the multiplicity. So this one's setting all these equal to 0, so this is going to give you x equals 5. That has a multiplicity of 2, so that's when you're going to have your bounce. This one is going to be x equals negative 2. That has a multiplicity of 1. Again, looking at these exponents for your multiplicity, if you don't see one, that's a 1. So this one's going to be straight through. If it asks you what would that behavior look like on a graph, this is kind of how you can explain it. And then this last one is x equals -5. This one also has that multiplicity of 2, so that's where you see that bounce. It hits it, bounces off of it. I wanted to show you this one because this kind of messes with you guys sometimes. So if you set this equal to 0, right, you're just going to get that x is equal to 0, and that has a multiplicity of 2 because it's squared out here. And again, that messes with you guys every now and again, so I want to make sure you saw it. This would again be one of those bounces. This 0 is x equals 4. It has a multiplicity of 1. So this is where you're going to see that straight through. And then this last one is at x equals -2. This one has a multiplicity of 3. Now you can describe that multiplicity of 3 as a lot of things. The actual vocab term is a point of inflection. So if you want to sound super educated, you can try it. You can put that if it comes up on the test. All right, last one we're going to do on this page is find the equation based on key features. So remember that we're writing our equation as that y equals a, and then it's your factors raised to their multiplicities. So if you start, it says that you have a negative leading coefficient. That's degree 4. So your multiplicities need to add up to 4. With zeros at x equals 2 and x equals 3 that have a multiplicity of 1. So if we start, we still don't know what our a value is. You can put the negative there if you want. Doesn't matter. We're just going to kind of use that as a check at the end. And so if it's at x equals 2, that's x minus 2, x minus 3, and they both have a multiplicity of 1. It also has a 0 at 0 that has a multiplicity of 2. So that's going to be like an x squared. Usually this is written up at the front, so if you want to rewrite it, you're going to see it written like okay, so it's going to be like that. Now, to find that a value, it tells you it goes through the point 1, -1. So we're going to take that and we're going to plug it in. So we're going to plug in -1 is equal to, we don't know our a, 1 squared, 1 minus 2, 1 minus 3. Okay, so this can be -1 is equal to, 1 squared is 1, 1 minus 2 is -1, 1 minus 3 is -2. So this is -1 is equal to +2. Divide by 2. Divide by 2. Your a value is equal to -1/2, which matches what this says here. We said that it was a negative leading. So you can write your equation as y equals -1/2 x squared, x minus 2, x minus 3. All right, tune into that next video if you need help with that next page.